Assalamu alaikum, my respected and my dear students. Today we are going to introduce new problem that is the common problem to all students, that is the balancing of equations. We know that balancing of equations have more than one methods. Ion electron methods available, redox methods available. There are the different rules to balance the equations. How we balance the equations via redox methods, there are some rules. How we balance the equations in the aqueous acidic media, how we balance the equation in aqueous basic media, the different rules basically. Today we are going to introduce how we can balance the equation in the acidic media. The example is the permanganate ions change into manganese ion. That's very simple equations. We start from the simple ones. How we start from this simpler solutions? After that, we can balance the periodate into iodate ions. First of all, we balance the permanganate ion into manganese ions. How we balance this equation step by step? First of all, before balancing equations, you should well know about the charges. In other words, oxidation states. What is the oxidation state of manganese in permanganate ion? Basically, oxygen have a -2 oxidation state, normal oxidation state. There are the 4 oxygens, 4 multiplied by 2 -8, and oxidation state for manganese is +7, and +7 and -8, 4 multiplied -2, that is a -1. Answer is -1, and that -1 oxidation state is represented by a negative charge on permanganate ion, and oxidation state of manganese is +2. It's mean manganese basically is changed from +7 oxidation state to +2 oxidation state. +7 to +2. It's mean it's the reduction process. +2 +7 oxidation state change into +2. It's mean that is change by gaining of electron, by gaining of 5 electrons. If we wanted to change from +7 oxidation state to +2 oxidation state, it's mean you must provide 5 electrons. Then this +7 oxidation state change into +2 oxidation state. After understanding the oxidation state, we balance the atoms on the both sides of the reactions. First of all, see that on the right hand sides and left hand sides, and manganese is 1 and 1, but on the left hand sides there are the 4 oxygen. To balance this 4 oxygen, we must put 4 water molecules on the right hand side. Now 4 oxygen on the right sides and 4 oxygen on the left sides. Manganese are balanced and oxygen is balanced, but another problem is created along the balancing of oxygen. That's the hydrogens. On the right hand side there is the 8 hydrogens are produced. 4 multiplied by 2, that's 8. To balance these 8 hydrogens, we put 8 protons and the left hand sides to balance the hydrogens on the both sides. It's mean manganese are balanced on both sides, oxygens are balanced on both sides, as well as our hydrogens are balanced on both sides. No, at the last we should balance the charges on the both sides. Let me explain in the simple one. See that 8 protons mean plus 8 charges. Permanganate have a -1 charge, and on the right hand side there is the +2 charges. Plus 8 and -1 is +7, +7 and +2. It's mean +7 oxidation plus in other words +7 charges on the left hand sides and +2 charges on the right hand sides. How we can balance these charges on the both sides? We put the -5 digits on the left hand sides, +7 -5, that's a +2, and the right hand side also +2. It means charges are balanced, +2 and +2, and we have put -5. -5 means 5 electrons. -5 means 5 electrons. You must put 5 electrons on the left hand sides to balance the charge on both sides, because the 5 electrons are donated 5 electrons donated to the manganese to change the oxidation state +7 to +2, +7 to +2. It means that is the reduction reactions. At the last we see that manganese are on the both sides are equals, oxygens on the both sides are equals, protons are equals, and charges are equals, +2 +2. Equations balance. That's very simple and easy method to balance the equation in acidic media, and every equations in acidic media can be balanced in this way. So simple.